else tomorrow. All right?
I just realized there's actually
I was speaking to a teacher,
Yep.
Mrs. B, Mrs. B yesterday.
All right. I've lost my things. Where am I? Here it is. Sit here. So that you're not. Oi. Some of you, the books are still in your bags. Still hiding in your bag books. I was actually reading through all your reports last night. It was very interesting to actually read what I say is about the same as what other teachers say. Things like being distracted in class, not actually paying attention. It's echoing over and over again with some of you. It's very interesting. So, hey. Now, what I really want all of you to do, especially at year 9 level, you're going to the next semester, half a year more, you're going to start thinking about as soon as you come in. Go ahead and put your book down. Thank you. You've got your bookmark now. You need to start thinking about bringing your things out, like book, your pencil, and pencil cases, and that sort of stuff. If you haven't got your books, you know I've got plenty of pencil and or plenty of papers here, and I've got pen and pencil for you can use. All right? And you don't need your laptop. You can put your laptop away. This is a better pencil. All right, I think the whatever is here. Oops. All right. Now, we are still looking at Pythagoras' theorem, which is a squared plus b squared equals c squared. And this time we are going to look at the three-dimensional. And Cohen has did a very nice drawing. And now, it is actually like this, not to scale. A lot of the drawing in the test or in the exams are not to scale. So please never think that anything that is drawn or anything you had observed is actually to scale. Alright? Now, 3D. I've got a question for you. You can look at that as well, but imagine this is that container there. Alright? If I want to put a pen or pencil in here, what do you think about how you can fit the longest thing? This is one of practical usage of Pythagoras' theorem. Can you? I can not put the pen in this way, can I? Yeah? Diagonal? Yeah, you can. This is alright because that's just perfect length.
But if you had like a longer thing, you could fit it like that.
Yep, longer thing like this. You can't, but that is how you could do it. So, what you can think of is, you've got triangles that go down, and, right, you've got a right angle triangle. Let's start off with looking at the base. The base, you can split that into a right angle triangle. Alright, this is not really right angle, but you've got to imagine that. Alright, right angle triangle. So you've got a right angle triangle here. Agree? Yeah? So if you know the measurements here, you can find the measurement there, the diagonal. Next, if I want to find the longest, again, you can see that it is a right angle, right? Alright, imagine this is a right angle. Okay? This, that, and that is hypotenuse. And this is the longest. You could work out, you got the height here. Now, from here and here, you could have worked out the diagonal. Correct? Yeah? You have worked out the diagonal. based on this right angle triangle. So now you've got that, the height, you can work out the longest object. Yeah? So that is what we're going to look at this stage. What is the longest object? One of the things that we're looking at is what is the longest object you can fit into one. It does not necessarily restrict to one of these. It could be a cylinder as well. If you think about a cylinder, all right? Ooh, okay. What you could do is think of this. This is the height, and then this is the diameter, right? And then that will be the diagonal. Got it? Yeah? So this is the height. If you use the diameter, that's the longest. And then that will be the diagonal. Alright? So now we can all visualize it. I like using some props to do some visualization because it's always actually good. Let's do some problem solving. Alright, so here, main thing, I showed you integer, fraction, and irrational number yesterday. Main thing to look at is 3D situation. We'll do more for sure. Alright, just a recap. Right angle triangle only. Pythagoras' theorem state that a squared plus b squared, the two shorter side. The square of the two shorter side, the sum of the square of the two shorter side must be the same as the sum of the square of the longer side, which is the hypotenuse. Alright? In this case, I use C. Alright, now, same problem. I don't know how Cohen read my mind. Here, how are you going to find S? How are you going to find D? This is a cube. So if this is a cube, that would be 4 centimeters as well, correct? Now, you could actually think about using calculator or not. If you don't use a calculator, I'm going to show you in exact values. And then we'll play around with the calculator. Exact value. Alright. What we're going to do is start off with S first. And then look at D. Here, we could redraw, if you like. We know that this is 4 by 4. Yep, correct. And this is S. So therefore, S equals the square root of 4 squared plus 4 squared, which is square root of 16 plus 16, which is square root of 32. All right? Now, like I say, I haven't taught you how to whatever yet. I haven't taught you how to simplify surds yet, so we can leave it at here at square root of 32. Now, note that I'm looking for S because here in the diagram there's already stated S centimeter. So I actually did not write down S centimeter. Right? Now, the next thing you need to look at, you know this is 4, the height. You know that this is square root of 32 centimeter. And you need to find the diagonal. What you can do is, again, Pythagoras' theorem, d squared equals to 4 squared plus square root of 32 squared. What is square root of 32 squared? 32, thank you. So it's 16 plus 32, which is 48. Therefore, d is square root of 48. Now, this is exact values. If you haven't got a calculator, come and get a calculator from me because I want to write down the decimal places. All right. Come and grab a calculator from me, thank you.
Thank you, sir.
Thank you.
X is a diagonal line. So if you look at this is triangle.
Yep.
This is triangle.
Oh, okay.
Right?
Oh, yeah.
Correct? Yeah? So square root of 32.
Yeah.
Let's do square root of 32. Yes? Sorry? Oh, hang on, let me. Yeah, what's wrong with the second triangle?
Well, there's nothing wrong with it, but instead of using a squared plus b squared equals c squared,
Yep.
you could use c equals a squared plus b squared square root.
Yeah, you can.
So they pretty much mean the exact same thing.
Sorry?
They pretty much mean the exact same
They're exactly the same thing. They are exactly the same thing.
thing. You're only using that just to make it easier.
Yeah, that's right. That's right. That's right. So square root of 32 is 5.65854, which is approximately 5.66 centimeter. All right. Square root of 48 is approximately approximately 6.928203 or 6.93 centimeter. All right. Now here you can see that these are irrational number because you cannot really write this out as fractions, and it goes on and on. All right, decimal versus exact value. Hey, exact values, normally you use a calculation, you will use the exact value, and at the end you use a decimal. You answer in decimal. All right, that's a general rule. You want something to be exact. All right, next question. Probably the last example I'll give you before you do some questions. Now here you are given a square pyramid. Has a height 5 centimeter and square base with length 4 centimeter. Find the length of the HBC. All right, now how on earth are you going to do it? You now know this. You know this. All right? Yeah? Agree? Yeah? You know that. And you know the height. You know that B, E, and C is a right angle triangle. But you don't know what E and C, what is the dimension of E and C? Sorry, not E and C, EC. You know that these are the same, and this is 4 centimeter. How are you going to work that out? Yeah?
You can work out BD first.
Yes, you can work out BD first and
then you can divide by 2, so it's...
thank you. Very good. Thanks very much, Ihan. So what you do is, there are two ways of doing it. Ihan's way is calculate BD. Thank you. BD. Alright? So BD is actually square root of 4 square plus 4 square, correct? Which is square root of 32, like what we have found just now. Now, BD and then therefore EC, which is the same as ED, will be square root of 32 over 2. Just leave it like this. You don't have to worry about anything else. Now, you know that this is a square. All right, another way of doing it. I'm just going to show you. Do you know, is this a right angle?
Yes. Yeah.
Because if this is square, the diagonal, when it crosses, that will be right angle. So you know that this and this, they are the same length. So if I let EC equals to L. All right? So L square plus L square equals to 4. Correct? Agree?
Yes.
Yeah?
Yes.
So we can do L square plus L square equals to 4. Correct? 2L square equals to 4. L square equals to 4 divided by 2, which is 2. L equals to square root of 2. Yeah, you can do it that way. Do you think that's right?
Mr.
Yes?
Why L squared plus L squared is equal to 4?
This is triangle, triangle. So this is One side and the other side, and that is the other. Correct?
Oh.
Yeah? Agree? So this, alright, let me highlight that bit. This is another right angle triangle, correct?
Oh.
Yeah?
Oh.
Agree?
Oh, yeah, yeah, yeah.
Agree? Do you agree?
Yeah. It's like
Yeah.
A square plus B square equals C square.
Yep. Yep. Yes?
Can't you just find the length of ACD
You can.
and then halve it because these sides are equal length?
Yeah, it's fine. Either way is fine. Either way is fine. Alright? So, let's go back to work on that. Equal side. So L squared plus L squared 2L squared equals to 4 squared, which is 16. What am I doing? That's 16? Oh,
That was in the note.
that's 16. That would be 16. So L squared equals to 8 is square root of 8. Alright? So it's my fault. Now you can see that we can simplify that to square root of 8. But I'm not showing you yet until next year. You'll do it next year. Alright, back to the question. Once you've worked out EC and ED, VC squared then, VC squared is then equals to,
5 square.
oh sorry, I don't need the square root sign yet. I'm just going to make it a little bit easier. 5 squared plus L squared, which is square root of 32 over 2 squared. Correct? Yeah, which is 5 squared is 25 plus square root of 32 square is 32, 2 square is 4. Correct? 32 divided by 4 is 8 plus 8, which is 33. Therefore, BC equals to square root of 33 centimeter. Now, if you're doing decimal place, square root of 33 equals to 5.74456, approximately 5.74 centimeter. Alright? So you should be able to look at 3D and think about how to work out the right angle triangle. This is one right angle triangle. I'll show you the other one.
They're still on.
Yeah, hang on 1 minute. This is the other right angle triangle. Right?
Fine.
Yep. What was the question?
It's probably a very easy question, but my brain isn't working. Root 8 is then turned into root 32 over 2.
Yep.
Bracket square. That's just not clicking with me.
Alright, okay. I will show you why root 32 is same as square root of 8, alright? Now, I'm going to finish the lesson. Oh, actually, no. I will do that now. Hang on. I will show you why 32, square root of 32 is the same as, whatever you call it, same as square root of 8. Alright. Now, let's start. Alright? You know that 32 is actually 4 times 8. Correct? Do you all agree? Shh. Yeah? Alright? So therefore square root of 32 is actually square root of 4 times 8. Correct? Yeah? Alright? So now, it's actually the same as square root of 4 times square root of 8. Correct? So what is square root of 4? 2. Square root of 8. Alright? Now, alright, go back one slide. Square root of 32 divided by 2 is 2 square root of 8 divided by 2. So you can cancel off the 2. Therefore, it's the same as square root of 8. Got it? Yeah? Absolutely right? Yeah? No, that's not going to be in the test. That's a year 10. That's a year 10 that I'm just showing you. Alright? You can further simplify square root of 8, which is 4 times 2, which is square root of 4 times square root of 2, which is 2 square root of 2. If you want to think about that in search, yeah?
What could 2 root 8 be expanded to? Is it 2 times root 8 or is it
2 root 8. So if it is 2 root 8, is 2 times square root of 8 is square root of 2 square. Hang on, yep. It's actually what I need to do is bring it into square root. Hang on, I need to get rid of that. That becomes square root of 4 times 8. Because you want to bring these two into the square root, so it's 2 square. So therefore it's square root of 32. Yes, what was the question? Natalie, what was the question? Yes, because the calculator is different. How do you show me what you do? Yes. Of course it's different. 1 square root of 32, 1 half, including square root of 4 times, 2 times square root of 8. 2 times square root of 8. Alright? Alright, I'm going to stop the lesson here. The last bit is actually the extension bit, so don't worry about the search too much.